In this lesson, we're going to look at RMAN maintenance. So how to do maintenance on RMAN backups. So we've said that RMAN is the preferred way of doing backup and recoveries on an Oracle database. However, there are some maintenance tasks that have to be accomplished, because if we set up our database to have weekly backups, let's say, those old backups need to be removed, and archive logs as well. So the archive logs are not needed past a certain point because our backups are newer than those archive logs. So all of that goes into maintenance for a database. We primarily gain information about the database and its backup status using two commands in RMAN, list and report. So let's go into RMAN, connect target, and do a list backup of database. All right, so this command is going to give us information about the backups that have occurred in our database. So it may give us things like the type of backups. Here it says full. Tells us the piece name, so exactly where the backup file is, when it completed, when its elapsed time was, or how long, what type, was it disk or to tape. And if we look a little further, we can see type INCR for incremental. And it's an incremental LV for level 0, the size, the data files that were involved. Here's an incremental level 1 as well. So that gives us the information about the backups that have occurred in our database. So list backup of database. One of the most important commands that we could use is to find out whether or not RMAN thinks that there are any files in the database that do need to be backed up. So this is really important in situations where sometimes if a backup fails, say for lack of space, what exactly got backed up, how much was completed, and what does RMAN think still needs to be done. So a report need backup command. So that will tell us whether or not RMAN thinks any data files need to be backed up. And notice that it comes back with no information here, so it's null information. So that tells us that there are no data files in our database that need to be backed up. Well, what if we were to add one? So let's go in here and create a table space. So now we have a table space named test10. Has a data file associated with it. So let's run that command again. And notice that as soon as we create that table space, it now says that data file needs to be backed up. So RMAN is smart enough to go out and know the state of the database. Now, another major command for maintaining our space, because we always have a limited amount of space that we could use for the fast recovery area, is to do report obsolete. So report obsolete is going to give us a list of all of the backups and archive logs and image copies or anything that we have in the flash recovery area that is obsolete and can be removed. So notice here that we have a number of files, archive logs, backup sets that can be removed. In order to remove these, we'll use the delete obsolete command. So when we do delete obsolete, the first thing it does is come back with the list of obsoletes. This is what we just saw with the report obsolete command. Do you really want to delete the above objects? So I'm going to type no here, because oftentimes if we script our backup, we don't want the interruption of it asking a question. If we tell it to delete, we want it to delete. That's the kind of commands we would put in an automatic scheduled job. So we would use delete no prompt obsolete. And then it will go ahead and delete those without asking us whether or not we want to do it. Notice that we have deleted archive logs, deleted backup piece, so on and so forth. So now if we say report obsolete again, no obsolete backups were found. And finally, the cross-check command. It's very important when you do RMAN backups that you use these commands to do your maintenance, to remove your files. Because if you go out onto the file system itself and you delete the backup pieces that you think are old enough or delete archive logs, then RMAN doesn't know about those because we didn't interact with RMAN when we removed them. And the way that RMAN discovers what is missing and can update its catalog is the cross-check command. So we would say cross-check backup of database. And then it gives a list of the backup pieces that it found. If there are any that it expected to be there that weren't there, then it will say that they are expired. And we can go and do cleanup from there using delete obsolete. In this lesson, we're going to learn how to perform an RMAN backup. So in order to do this, first and foremost, we need to log into RMAN. So we simply launch this from the command line with the RMAN command. Then we need to connect to the database. So we say connect target. So right now our database is open, and our database is also in archive log mode. So it's important here to talk about the difference when we're doing backups between hot backups and cold backups. So a hot backup will occur when the database is up and being used by users, or certainly can be, and a cold backup would be when the database is not available for users. If we're running in no archive log mode, we must back up the database cold. We cannot run a hot backup. And that's one of the reasons that archive log mode is so important. So if we are in archive log mode, then we can back up the database while it's available. Nevertheless, either way, one of the strengths of RMAN is that the commands to do the backups are the same, whether the backup is cold or hot. And so we can do a simple backup is all we have to type in order to back up whatever particular entity we're interested in. So we can back up a data file, back up a table space with all of its associated data files, or we can back up an entire database. So let's try this by doing a backup table space users. All right, notice a few things about the output here. It says it's using the target database control file instead of a recovery catalog. So the control file is going to be the default repository for data file information as far as what's been backed up. It's allocated a channel, specifying a data file in the backup set, and it says it's data file number 4, gives us the location for that data file. It says it's starting piece and finishing piece, and a piece is the term for a backup file, the data that gets written out from a backup. Then gives you the location of the backup piece, and notice that it's in the fast recovery area. If we were to look in our fast recovery area, we would see a folder for backup set, the date, and then the name of the backup file that we have. So to do a full database backup, we would only need to type in backup database and hit enter and allow it to run. We can also do backup data file 4, which is the same data file associated with the user's table space. Although we can interact with RMAN in this really interactive way, we can also script our backups to be a little more involved. And to do that, we use what's called a run block. So we begin with the command run, bracket, and then our individual RMAN commands. So by default, RMAN is allocating a channel to do work, but we can do that ourselves as well. And we would do this if we wanted more than one channel, and sometimes we can increase performance by having more channels. And we can say backup. And in order to run this, let's go ahead and try a compressed backup. So we could just simply do backup database and then close it out. But we could also say backup as compressed backup set database, semicolon, and then end the brace. And so when we hit enter, Oracle is going to run a full backup of the database, and it's going to compress the backup pieces on the fly. And then the backup is complete. And so it gives us information as far as where the backup piece is located, again in our fast recovery area, and then shows that it's complete, releases the channel, and returns control back to us. So RMAN, if we look back, can be as simple as one-line commands, or more involved if we want more control over our backup. In this lesson, we're going to discuss complete recoveries with RMAN. Now, a complete recovery is going to be a recovery where all the data is recovered up to the point of failure. So what we're going to do in this example is actually simulate a failure and perform a recovery. So it goes without saying that in order to perform a recovery, we must have a good backup. So we ensure that we have a good backup before we attempt to simulate a media failure. We need to remember that when we do a recovery, it must be done in the mount state. So the database must be in mount. We cannot do a database recovery while the database is in no mount state or an open state. And indeed, if we have a media failure, it's not very likely that the database would be in an open state, at least in any functional way. When we do complete recoveries, we can do them much in the same way as backups. So we can do them at the table space level, the data file level, or the entire database. And a recovery involves two steps: restore and recover. Restore is restoring the backup, the file from a backup, and recover is the act of rolling it forward, applying all the changes that have occurred that are in the redo logs and archive logs. So restore and recover. So in order to simulate this, log into RMAN, connect target, and shut down the database. In this case, we need to shut down the database because Windows will prevent us from actually doing what I'm about to do, that is to change the name on a data file, simulating its loss, because it locks the files when the database is open. However, on Linux and Unix, you are free to go and destroy a file, one of the data files of the database, without the operating system stopping you. The database is shut down, and so I'm going to go to the directory that holds the data files. Oracle base directory, there'll be an Oradata, the name of the database, and then data file. And so I'm going to target the data file that belongs to the user's table space. And just for slight safety's sake, I'm just going to rename this, rather than delete it, to .old. However, the effect is the same, because when the database attempts to start, it will have a problem because it will not find this data file that it expects to be there. The data file locations are written in the control file, and it expects all of those to be there when the database startup occurs. I'm going to exit out of here. SQL plus is sysdba. And now we're going to just type startup and see how far we get. So notice that the instance started and gave us the information about the memory, and the database made it to mount state, but it couldn't get any farther than that. It says, I cannot identify our locked data file number 4, and then gives us that file. And there it is, the data file that belongs to the user's table space. And so it cannot see it. So it's as if we just went ahead and deleted it. So now we are already in the mount state, so we're in a position that we can restore and recover this data file. So we say restore data file 4, and that again is the number of the data file that's indicating is missing. And we need to be in RMAN to do this. The RMAN connect target, restore data file 4. So what it's doing right now is reading the backed up data for data file number 4 from our backup, and it's restoring it. And if we were to see, notice that it has restored a data file for the user's table space. But we're not finished, because we need to recover all of the data that was lost between the time that the database was shut down and when the data file was lost. So we say recover data file 4. Starting media recovery complete, and now our database is ready to be opened. So we do alter database open. So what would we do in the event of a complete loss of the database? So what if we lost all of the data files in the database? If I had actually just removed those files that are here under the data file directory? Well, the process would be very, very similar. We would simply type restore database and then recover database. And following the activity that occurred, our database would be fully recovered and restored.